Here is a combined summary of the 2 pages. Machine learning models are increasingly being deployed on edge devices, such as smartphones and IoT gateways, to provide various services. However, this deployment is accompanied by challenges in model privacy and auditability. Model providers want to ensure that their proprietary models are not exposed to third parties and that they can get attestations that their genuine models are operating on edge devices in accordance with the service agreement with the user. Existing measures to address these challenges have been hindered by issues such as high overheads and limited capability on edge devices. To address these challenges, the authors propose GuaranTEE, a framework that provides attestable private machine learning on the edge using confidential computing architecture, CCA. CCA allows for the creation and deployment of dynamic trusted execution environments, TEEs, within which models can be executed. The authors evaluate CCA's feasibility to deploy machine learning models by developing, evaluating, and openly releasing a prototype. They also suggest improvements to CCA to facilitate its use in protecting the entire machine learning deployment pipeline on edge devices. Prior work has shown that on-device models are susceptible to various attacks, and existing solutions have limitations. Watermarking techniques can detect model theft but not prevent them, and cryptographic techniques such as homomorphic encryption and secure multi-party communication are hindered by computational and communication overheads. Hardware-assisted techniques, using trusted execution environments, are a performant alternative to cryptographic techniques. However, many TEE solutions are tailored towards cloud environments and not applicable to edge devices, which have limited memory and computational power. The authors' contributions include developing GuaranTEE, a framework that allows for machine learning models from a provider to be run on end devices in a private and verifiable manner. They explore CCA's potential and limitations to implement GuaranTEE, and develop and evaluate a prototype using ARM's Fixed Virtual Platform Simulator. The preliminary results indicate that running a TensorFlow-Lite image recognition model within a realm for inference results in an overhead of 1.7 times the number of instructions required to run it within a normal world virtual machine. The authors discuss challenges involved in implementing their prototype using CCA and potential enhancements to the CCA architecture to enable better protection of the machine learning pipeline on edge devices. Here is a combined summary of the 2 pages. GuaranTEE is a system that enables attestation and privacy for machine learning models using ARM's confidential computing architecture, CCA. Unlike TrustZone, CCA allows for the creation of dynamic, hardware-protected enclaves called realms, which can be used to deploy entire machine learning models. This approach addresses the limitations of TrustZone, including reliance on a trusted OS, limited memory, and development cycle restrictions. CCA provides a more secure environment for ML deployment by introducing a new execution environment, the realm world, which is isolated from the normal world. The realm world has its own dedicated memory, and the hypervisor is not allowed to access it. CCA also introduces the Realm Management Monitor, RMM, a lightweight firmware that manages communication between a realm and the hypervisor, ensuring isolation between realms. The system, GuaranTEE, uses CCA to run models in a private and attestable manner. It consists of 3 parties: model providers, clients, and a trusted verifier. The model provider trains and deploys machine learning models to clients, while ensuring that the client's suggested execution environment is trustworthy. The client is an end device supporting the ARM9A architecture, and the trusted verifier provides verified realm images for clients to run. The threat model assumes that the model provider does not trust the client and wants to prevent the client from accessing the model's internals. On the client side, the secure monitor and the RMM are assumed to be trustworthy, while the normal world, including user-space apps and the hypervisor, are malicious. The system aims to ensure confidentiality and integrity for the realms even when the hypervisor is compromised. Prior work on CCA includes VirtCCA, a virtualized CCA implementation on top of existing TrustZone hardware, and Shelter, which provides user space isolation in the normal world using CCA hardware primitives. GuaranTEE builds upon these concepts to implement a system that uses CCA realms to run models in a private and attestable manner. Here is a combined summary of the 2 pages from the research paper. GuaranTEE is a novel framework that enables attested and private machine learning (ML) model execution on client edge devices. The framework consists of a pipeline that involves deploying a model on a client device, establishing a secure connection with a model provider, and performing inference while ensuring the integrity and confidentiality of the model. The pipeline begins with the client obtaining a realm image from a trusted third party and creating a realm virtual machine (VM) on the client device. The realm VM is then activated, and a secure connection is established with the model provider. The model provider sends a request for an attestation report to the realm, which includes the attestation of the platform and the state of the realm. Upon verification, the model provider sends the model to the realm, and the realm announces its ability to respond to inference queries. The ML deployment lifecycle involves not only the main operation of the model, i.e., inference, but also other aspects such as model updates and termination. The realm may need to periodically query the provider to check for and receive updates, and the provider may need to verify the state of the realm before sending the updated model. The authors implemented a prototype of GuaranTEE on ARM's fixed virtual platforms, FVP, due to the unavailability of a CCA-compatible board. The software stack consists of the reference ARM CCA integration, trusted firmware A, and Linuxca as the hypervisor. The authors deployed a TensorFlow-Lite model within the realm and evaluated the overhead of running inference within a realm compared to a normal world VM. The evaluation results show that running the model inside the realm leads to a 1.62x overhead in the number of instructions executed for each inference process compared to running the model inside the normal world VM. The increase in instructions is mainly due to the higher number of context switches the hypervisor needs to manage the realm and handle its interrupts. Additionally, creating a realm VM incurs a significant overhead, 26.62x, compared to creating a normal world VM. The GuaranTEE framework utilizes the Confidential Compute Architecture, CCA, to provide machine learning, ML, model protection and attestation on edge devices. The prototype, developed using the Fixed Virtual Platform, FVP, simulator, demonstrates the feasibility of using FVP to build CCA-compatible prototypes of various stages of the ML deployment cycle. The results indicate that running a model within a realm for inference incurs an overhead of 1.7 times the number of instructions required for running it in a normal world virtual machine. However, several challenges and limitations are identified, including the need for modifications to the FVP platform and the underlying CCA architecture to fully realize the vision of private and attestable learning at the edge. Specifically, the current implementation does not provide protection for the input data and inferences, and the CCA architecture does not currently offer dedicated solutions to secure the inputs and outputs to the model. Future work includes exploring methods to provide greater availability guarantees, extending the CCA architecture to include functionality for policy enforcement and improved runtime realm attestation, and measuring performance when running multiple realms in parallel. Additionally, mechanisms to ensure that the ML pipeline is operational in accordance with the agreement between the client and the provider need to be employed. The paper also highlights the importance of secure peripherals, detection mechanisms within the realm, and the need for a trusted verifier to ensure that the model provider's code will not use the client's data for purposes outside the agreed-upon ones. Furthermore, the paper notes that the hypervisor controls the creation and execution of realms, which can cause denial of service for the client. Overall, the GuaranTEE framework provides a promising approach to attesting and protecting ML models on edge devices, but further research and development are necessary to address the identified challenges and limitations. The research paper discusses the development of GuaranTEE, a novel system designed to enhance the security and privacy of machine learning (ML) models deployed on mobile devices. It leverages the ARM Confidential Compute Architecture (CCA) for trusted execution environments, ensuring that ML models are protected against unauthorized access and data breaches. The paper also provides an overview of various existing solutions for securing ML models, including model watermarking, fingerprinting, and encryption techniques. The authors emphasize the importance of protecting ML models as they become increasingly integrated into mobile applications, highlighting potential risks such as model extraction attacks and privacy violations. They argue that current approaches to securing ML models are insufficient, particularly in terms of their complexity and resource requirements, which can limit their practicality in real-world scenarios. GuaranTEE addresses these challenges by utilizing the CCA's secure world to execute ML models, thereby preventing direct access to the model parameters. This approach not only protects the confidentiality of the model but also ensures that the model's output remains private, safeguarding user data. Furthermore, the system allows for efficient model updates without exposing the model itself, enhancing its usability and adaptability in dynamic environments. The paper presents a comprehensive evaluation of GuaranTEE, demonstrating its effectiveness in securing popular ML models like MobileNet v1 while maintaining acceptable performance levels. It also discusses potential limitations and future directions, such as extending the system to support more complex ML models and improving its compatibility with different hardware platforms. In conclusion, GuaranTEE offers a promising solution for securing ML models on mobile devices, leveraging the CCA to provide robust protection against various threats. As the integration of ML models into mobile applications continues to grow, the development of such secure and efficient systems becomes increasingly important to ensure both model confidentiality and user privacy.